this video, we are to evaluate this integral on residual definite integrals. So to start with, you know that sine theta is given as exponential I theta minus exponential minus I theta divided by 2I. Remember this from this complex analysis, of course, and this is the formula for sine theta. So also for that of cos theta, we have it to be exponential I theta plus exponential minus I theta divided by 2. So we have sine theta to be this and cos theta to be this. So now here let's assume z to be equal to exponential I theta. So if we assume z to be equal to exponential I theta, that means sine theta will become z minus z inverse divided by 2I, and then cos theta will become z plus z inverse divided by 2. So this is what you have. Alright, so now let's look at if z is equal to exponential I theta, then if z is equal to exponential I theta, then the z will be equal to I exponential I theta. The z will be equal to I exponential I theta d theta. So that means the theta will be equal to the z divided by I exponential I theta. So but from here you can also note that this is equal to Iz, because remember z is equal to exponential I theta, then I exponential I theta means you have Iz. So, and this is also the theta here, so that means apparently this will become the z divided by Iz. So that's what. So let's substitute all of this into this formula here, where we have integral from 0 to 2 pi of 1 divided by 3 minus 2 into, we now have cos theta to be exponential I theta plus exponential minus I theta divided by 2. Then you have plus sine theta, which is exponential I theta minus exponential minus I theta divided by 2I. So instead of having the theta, now we are going to have the z over Iz. So we have this to be integral of 1 divided by, let me bring this to this side for convenience sake, then we have 3 minus, to open this bracket, 2, we divide 2 here, and we'll be left with exponential I theta plus exponential minus I theta plus, then here we have exponential I theta minus exponential minus I theta divided by 2I, and we have the z. So this is integral of 1 divided by Iz into 3 minus z. Remember, this is equal to z and this is z inverse plus z minus z inverse over 2c. So this will give rise to 1 all divided by of Iz here into, this is 2, now I'm taking the LCM, this is 2I here, 2 times this, you have 6i, minus 2 times the whole of this, you have minus 2zi, minus 2z inverse of I. Then we have plus z minus z inverse, all divided by 2i, and this is dz. So from here we are going to have integral I will divide I there, and these two will go up, will become 2 divided by, and we have z here. Opening this bracket with z, we have 6iz, we have minus 2i z squared minus 2i plus z squared minus 1, and this is the z. So this is going to be equal to, we can always bring these two outside and we'll still be left with 1 divided by, now we have it to be, so at this point we can collect some like terms. We have z squared minus 2iz squared here, then we have plus 6iz, and we have minus 2i minus 1 dz. So this is 2 integral of 1 divided by, then we have z square here, we have 1 minus 2i plus 6iz, and we have minus 2i plus 1 dz. So this is what we have. So let's look at, I haven't reduced this now, let's look at our denominator. If we look at our denominator carefully, we have it to be z squared. Our denominator, we have our denominator to be z squared into 1 minus 2i plus 6iz minus 2i plus 1. Let's compare this with the quadratic equation ax squared plus bx plus c equal to 0. So you discover that from here now we are going to have a to be equal to 1 minus 2i, we are going to have b to be equal to 6i, I'm going to have c to be equal to minus 2i plus 1. So now we are going to solve this using quadratic equation, using the quadratic formula, which we have to be z. In this case, z will be equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So we substitute all these values in this formula. If we do that, we're going to have z to be equal to minus b, here we have minus 6i plus or minus square root of 6i squared minus 4 multiplying 1 minus 2i, then we have multiplying c, which is minus 2i, and multiplying c, which is minus 2i minus 1. Then all of this is dividing 2 multiplying a, which is 1 minus 2i. So let's solve this further. We're going to have minus 6i plus or minus square root of 36i squared, that is minus 36. Let's write it directly, minus 36 here, then this is minus 4, so let's put it this way, 4 minus 8i multiplying minus 2i minus 1 divided by 2 minus 4i. So this will give rise to minus 6i plus or minus square root of minus 36 plus 20. If you multiply these two, you are going to have 20. So this is what we have here, and this is dividing 2 minus 4i. So z will be equal to minus 6i plus or minus square root of, we have minus 16 divided by 2 minus 4i, which is going to be minus 6i plus or minus 4i divided by 2 minus 4i, and this will be equal to, we have 6, we have 4, we have 2, we have 4. So 2 is a common factor here. So dividing everything here by 2, we are going to have minus 3i plus or minus 2i divided by 1 minus 2i. So this will be equal to, now depends, the value of z depends. Z now will be equal to minus 3i plus 2i divided by 1 minus 2i, which will be equal to minus I over 1 minus 2i, or the value of z will be equal to minus 3i minus 2i divided by 1 minus 2i, which will be equal to minus 5i divided by 1 minus 2i. Let's go to the next page to solve this more clearly. So rationalizing the denominator now for the value of z equal to minus I over 1 minus 2i, this is going to be minus I divided by 1 minus 2i times 1 minus 1 plus 2i divided by 1 plus 2i. So doing this now, we have minus I into 1 plus 2i divided by 1 squared minus 2i squared. So this is going to be minus I plus 2 divided by 1 minus 4. So this is minus I plus 2 divided by 1 plus 4, which is 2 minus I divided by 5. So also let's look at the value of z, which is equal to minus 5i divided by 1 minus 2i, which will be minus 5i divided by 1 minus 2i times 1 plus 2i divided by 1 plus 2i, which is equal to minus 5i into 1 plus 2i divided by 1 minus 2i squared. So this is equal to minus 5i plus 10 divided by, this is 5, divided by 1 plus 4 as usual. Then here we are going to have 10 minus 5i divided by 5. Dividing both sides by 5, we are going to have 2 minus I. So let's compare these two values. Now. We have z to be equal to 2 over 5 minus I over 5, and we have it to be equal to 2 minus I. So if we compare these two values very well now, we discover that this one applies more. It lies within C. Let's say you have a circle there, and then it means it lies within C. This is your 2 over 5 comma I over 5. It lies within C. So we're going to make use of this one here. So making use of that now, we're going to have we have z to be equal to 2 over 5 minus I over 5, and the order here is 1. So we're going to make use of this, and this is our pole and this is our order. So remember our formula, a minus 1, which is equal to limit as z turns to 2 over 5 minus I over 5 of what? of 1 all over 1 minus 1 factorial, the 1 minus 1 divided by the z1 minus 1 into z minus into 2 minus I divided by 5. Then we have multiplying f of z. Remember, our f of z is 2 divided by z square into 1 minus 2i plus, this is I here, plus 6iz minus 2i minus 1. So this is what we have. So in the next sheet we are going to be evaluating this more clearly. So remember, this is going to reduce, of course. We'll be left with limit as z tends to 2 minus I divided by 5, and this tends to 0 factorial, this turns to 1, and all of that is 1. So we are going to be left with z minus 2i, z minus, we'll be left with z minus 2 minus I divided by 5 there, then multiplying 2 divided by z square into 1 minus 2i plus 6iz minus 2i minus 1. So let's expand this. We have a minus 1 to be equal to limit as z turns to 2 minus I divided by 5 into, multiplying this with this, we are going to have, and this we are going to have 2 into 5z minus 2 plus I now, then divide by 5, and all of this divided by z square into 1 minus 2i plus 6iz minus 2i minus 1. So this is limit as z turns to 2 minus I divided by 5 into, we have 10z here minus 4 plus 2i divided by 5 divided by z square into 1 minus 2i plus 6iz minus 2i minus 1. So now we are going to differentiate this. That means we are solving this limit using a L'Hopital rule. We'll differentiate and substitute. So differentiating this now, we are going to have limit as z tends to 2 minus I divided by 5 into, remember, you keep the denominator constant, differentiate the numerator. If we do that here, we are going to have 10 divided by 5 raised to the power of 2 divided by, now we differentiate the denominator, which we are going to have 2z into 1 minus 2i plus 6i. So a minus 1 now will be equal to limit as z turns to 2 minus I divided by 5 into, we have 50 divided by 25, and this is dividing 2z into 1 minus 2i plus 6i. So we are going to have limit as z tends to 2 minus I divided by 5 into 50 divided by 25. We are going to have 2 divided by 2z into 1 minus 2i plus 6i. So now we can directly substitute our value of z here, which we are going to have it to be equal to, 2 divided by 2 into z, which is 2 minus I divided by 5, and this is multiplying 1 minus 2i here and plus 6i. So let's solve this to the end. Let me change the ink from here. So a minus 1 will be equal to 2 divided by, now let's open this bracket. If we open this bracket now, we are going to have, okay, let's separate this first of all. 2 over 5 minus I over 5, and this is into 1 minus 2i plus 6i. So this is 2 divided by 4 over 5 minus 2i over 5 into 1 minus 2i plus 6i. So this is 2 divided by 4 times 1, we have 4 over 5. Then minus this times this, we're going to have 8i over 5 plus this times this, we have minus 2i over 8, and this times this, we are going to have minus 4 over 8 plus 6i. So in square we have 4 over 8 here, 4 over 5 rather. This is 5, not 8. This is 5. So this is also supposed to be 5, not 8, sorry. Then this is 5. This we subtract this, and you are left with this, which is going to be equal to 2 divided by minus 10i over 5 plus 6. A minus 1 will be equal to 2 divided by minus 2i. So a minus 1 will now be equal to 2 divided by minus 2i plus 6i. Remember, this is 6i here. Then this will be equal to 2 divided by minus this plus this, we are going to have it to be 4i. So this is approximately 1 over 2i. So this is your value of, so a minus 1. So we are going to substitute this into the residual theorem formula, and we will complete our solution there. So applying the residue theorem formula, where we have integral of cf of z, the z to be equal to 2 pi I multiplying a residue 1 minus 2, a minus 1 rather. Then we know this to be equal to 2 pi I now into 1 over 2i. So I will divide I, 2 will divide 2, you'll be left with pi. You'll be left with pi. So that means our answer here, integral from 0 to 2 pi of 1 over 3 minus 2 cos theta plus sin theta d theta will be equal to pi, as proved. Please like this video, subscribe to this YouTube channel, and don't forget to hit the notification bell to get notified each time we upload a video. Thank you.